Hey y'all, welcome back to my channel. So today we are continuing the geometry series of the Math Madness videos, and we are looking at the area of quadrilaterals. So we already have a video of area of triangles, so today we're looking at those. Don't forget, I do make a mistake for my students just to identify for extra credit, and don't forget to leave in the comments if there's any other content or topic that you would like to see a video on. So let's get started. Okay, area of quadrilaterals, and don't forget that's my YouTube channel so that you can subscribe, and then this is my Instagram that you can keep up with content that I post and send me questions or anything like that. Okay, so first we're going to look at the formula for the area of a parallelogram. Now, the parallelogram is a lot like, well, let's kind of talk about different things that can be considered a parallelogram. You have just a parallelogram. You have a rectangle, and then a square, and then you also have a rhombus, but we're going to talk a little bit about a rhombus here in a minute. But these are all of the shapes that you can use this formula with, and because rectangles and squares are a special type of parallelogram. So the formula is A equals base times height. Now, a lot of people, especially for rectangles and squares in 5th grade, 4th grade, when you start talking about area, they will say A equals length times width, which is correct, and that's the same thing, but with a parallelogram, you really have to look at the base, and then there will be a dotted line from top to bottom. Remember, height is the top of the shape to the bottom of the shape. So if we use this slant, that wouldn't be the true shape or the true height of that shape. So this is the height. And don't forget, on a rectangle and a square, that you can use the length, and then you can also use the width, because on a rectangle and a square, that width would be the height of the shape. You can use that side length to show that measurement. Okay, a trapezoid. So the formula for a trapezoid is A equals 1/2 times the height times base 1 plus base 2. And so I'm just going to label here that this is the height. B1 stands for base 1. And B2 stands for base 2. So let's label this shape over here. So looking at this formula, we have base 1 plus base 2. And a lot of my students are like, well, which one's the base 1, which one's base 2? Unless it's a word problem and it tells you, hey, this is base 1, this is base 2, then because of the commutative property of addition, it doesn't matter which way we put these numbers in, it's still going to be the same answer. No matter how you add them, it's still going to be the same. So we have these two will be considered the bases. I always tell my students, this cannot be considered a base because it's a slant. You need what it's kind of sitting on. You need the parallel, because these two lines are not parallel. The two parallel lines are your bases. Then you will have a dotted line, or don't forget, because a lot of my students get confused with this, this is considered a trapezoid as well. Notice these two lines aren't parallel, so that means those can't be your two bases. So here would be your base. These two would be your bases. Notice that this looks like the side of a rectangle, so this is showing you the top of the shape to the bottom of the shape. So you could use this as your height, but this one, if it looks like this, they will have a dotted line to show that height for you. So that is the information that you need to plug in to that formula. Okay, so now here's the rhombus. This is why I wanted to show you. So if it is a true rhombus, or sometimes to know that you use this formula, they're going to give you the diagonals. So if they gave you the base and the height, you can use that parallelogram formula. That's okay. So you can do that. But if they give you the diagonals, you need to use this formula. So D1 just stands for diagonal. I'm a math teacher for a reason. Can't really spell that well. So diagonal 1, and then D2 is diagonal 2. And since there's no signs, you will multiply all those. So 1/2 times D1 times D2. So just as I was saying with that addition, the commutative property of multiplication says it doesn't matter which order you put it in, you're still going to have the same product at the end. So we can just label that D1 and D2, but it really doesn't matter which one you plug into here. Unless, like I said, it's a word problem and it says, hey, this is diagonal 1, hey, this is diagonal 2. Now, the steps for solving is very similar to the triangle steps. So you're going to write the formula, you're going to plug into the formula, then you're going to solve the formula, and don't forget to write your units squared. Remember, area is always squared, and circle your answer for the reader so it is easier to find your solution. Okay, so here is our first shape. Now, we do have 2 sets of parallel lines, so that makes it a parallelogram. So I'm going to use the parallelogram formula, which is A equals base times height. And in this case, we couldn't use length times width because I don't have that right angle. I don't have 2 sets of parallel lines with right angles. That's why I can't use that length times width. So let's plug in. Here is my base, and then I always say use that dot for multiplication, because once you get into equations and expressions and using those variables, an x might look like a variable. So here is our dotted line showing us that from the top of the shape to the bottom of the shape is 5 inches. So then you just multiply. 10 times 5 is 50. Our units are inches, and since we did multiply 2 different measurements, I do need that squared on my units. Because just like triangles, the perimeter, you would just have inches. But we're finding area, so we do need that squared. Okay, so here is another parallelogram because we have 2 sets of parallel lines, but on this one we do have those right angles, so we could use that length times width formula. We could, and it's the same thing as the base and the height, because the length, we can consider the base, times the width, which is also the height because it's showing the top of the shape to the bottom of the shape. And then we multiply, so 20 times 7 is 140. Our units is feet squared. And then don't forget to circle your answer. And remember, it's so important to write that A equals, A equals, A equals, and write that formula. Put your measurements exactly below your formula, because, or each variable that represents that measurement, because it's so important to get into that habit of doing that for when you start solving equations and expressions. Okay, so this is a trapezoid because we only have 1 set of parallel lines, and then the other two are not parallel, but we still have 4 sides, which makes it a quadrilateral. So on this one, our formula that we have to use is A equals 1/2 times height base 1 plus base 2. Now, this formula is the biggest one that my students have a problem with because they don't bring that 1/2 down, or they start jumbling. They rewrite the formula in a completely different way. So area is all, well, area and volume. Anything that you have a formula with is my favorite because all you have to do is just plug in what you know. We don't know the area because we're finding it. That 1/2 just comes straight down. No sign. I have to have multiplication. So now I have to be careful where I plug in what numbers, because on the parallelogram formula and the rhombus formula, it really doesn't matter what numbers go where as long as you're plugging them into your measurements here and not your area. But on this one, it's so important. You need the height. You need that measurement that's going from the top to the bottom, which is 8, parentheses, and then I need base 1. Remember, it doesn't matter which one I use as base 1, but I always just kind of use the one that they're sitting on. So base 1 plus base 2. So now order of operations comes into play here. So don't forget order of operations, parentheses, exponents, multiplication, division from left to right, and addition and subtraction left to right. So this one I do need to do the parentheses first. So that would be 10. I'm just going to bring everything else straight down. Now here, there's no sign, and then you have the multiplication sign. So now I can just multiply however. So I'm going to do 1/2 times 8, which is 4, and then 4 times 10 would be 40. So then don't forget your units, and it is area, so it needs to be squared, and circle your answer. Okay, so here is another parallelogram. We do have 2 sets of parallel lines, but we can't use that parallelogram formula because we have diagonals. They gave us our diagonal measurements. So that's when we need to use that rhombus formula, which is 1/2 times diagonal 1 times diagonal 2. So now, since it's all multiplication, it doesn't matter which one I'll use as diagonal 1, diagonal 2. So I'm going to have 1/2, no sign, which means multiplication, times 6 times my other diagonal, which is 7. So then I'm going to solve. So 1/2 times 6 is 3. 3 times 7 is 21. And then my units is feet. And don't forget to circle your answer. Okay, and we do have a word problem for this video. So the length of one base of a trapezoid is 14 feet, and the length of the other base is 10 feet. The height is 8 feet. What is the area of the trapezoid? So don't forget that we love using or having word problems because it tells us right here that our shape is a trapezoid. So I know I need to use the formula A equals 1/2 height times the height times base 1 plus base 2. And I tell my students, write that formula every single time. Even though you might think, oh, I know the formula, I'm just going to plug in my numbers without writing it down. It's so easy to make that mistake. And so if you write down everything, if you show your steps, if you get it wrong, you can go back and look where you went wrong. So let's start plugging in. So right here it tells us one base is 14 feet. And then the length of the other base is 10 feet. Then it also tells us that the height is 8 feet. So when I'm plugging in, I have 1/2 times my height. Well, right here it says height is 8 feet. So I'm going to plug in 8. Then I have parentheses, base 1. It didn't really say like base 1 is this, base 2 is this. So I'm just going to use it as I see it. So I first see 14 plus the other base is 10 feet. So now I've used all of my measurements. Now I'm just going to solve. And don't forget, we need to do order of operations, so parentheses first. So 14 plus 10 is 24. and then 1/2 times 8 is 4, and then 4 times 24 is 96. And then right here our units is feet. So then don't forget area is squared. Circle your answer. Even though it is a word problem, you can say, come to the side here and say the area is 96 feet squared. Thank you all for watching. I hope that this helped you and is a good review for the area of quadrilaterals and all of the formulas. So don't forget to give this video a thumbs up. Don't forget to hit that red subscribe button so that you can stay on top of all of the videos that I post and get notifications so you can keep reviewing and getting help while you are working at home. So we will see you next time with the video of finding the volume of rectangular prisms. Bye, y'all.